Hey guys, it's Edward. So today, what I'm going to do is do a follow-up video to my previous LeetCode problem solving video that I did before. If you haven't seen that, I'll link it up here. But what I'm going to do today is look at two solutions that my clients have given me as they have tried to attempt to solve this problem. I'll be grading these solutions as if it were my own. I'll look at the differences between what they submitted and the optimal solution and show you how they can learn from mistakes. This is the same process that I use to learn from my own mistakes whenever I get a LeetCode problem wrong. I'll be going through my process and thinking as I try to analyze each one of their mistakes as if it were my own. I'll compare their solution to the optimal solution, and finally, I'll look at the big takeaways that each of them can learn from just simply doing this exercise. And hopefully, by doing this exercise and process and watching this video, you guys can actually learn how to learn from your own mistakes for your own studies. So with that, let's begin. So to recap the previous video, what I did was derive an optimal solution by simply taking a normal naive solution and then building upon it piece by piece. I took what worked and then tried to ask myself every single time what was the inefficiency and how I could eliminate that in order to achieve better runtime or space complexity. And so I'll show the solution very briefly right over here. Now with that in mind, let's actually try and figure out where each of these clients went wrong. So let's start with my first client here. In this first client, you can kind of see here that he was able to actually try and test the problem out. He's looking for patterns which he can use and abuse in order to try and solve the problem. So he just tries a few numbers in the array and then tries to map out what the solutions are. So this is a very good sign that he is actually trying to understand the problem. This is exactly the first thing that I did in the optimal solution. However, if you go here, you can see that he just expands upon the original array. Now, why does he do this? It doesn't really make sense. If you try to compare the optimal solution and what he did, you can see here that all he did was add extra values that seem to not really give him any extra insight. Whereas with the solution that I provided, I didn't actually have to do this. In other words, you can interpret this as just wasted effort. Now, he does have some intuition that you might be able to derive something through sorting, but that is just mostly a sign of trying to shoot something randomly in the dark. And so my first observed mistake in this problem is simply just creating another test case that doesn't add any value to what he is doing. In fact, this is just wasted effort. It doesn't test anything new that this original array does. Moving on, he actually was able to come up with a naive solution. Now, this is very similar to what I did for the very first naive solution. So at least he got to this point. However, you can see here as we scroll further down that he just ended up coming up with more pseudocode. Well, that is inefficient, because if you look here, there is nothing here that is really not reflected by whatever is put here. In fact, this is just redundant extra effort that doesn't seem to actually add any meaningful information or make any more progress towards the solution. Again, comparing to the solution that I have proposed before, it doesn't seem like there's any additional benefit or insight, and this is just more wasted space. So this is the second mistake that can be learned from, that simply just going over and retreading the same ground without getting anything more out of it is just a big waste of effort. So why does he do this? Probably because he needed a little more clarity into whatever he was thinking, which means that he should have already understood that, whether it was doing the examples or just by simply writing the pseudocode. This tells me as the interviewer that he is simply going through the template and motions of whatever system that he has in his head without actually thinking about it critically. Now, this is very good if you are a beginner and just trying to get into the basics of problem solving. However, at some point, you can start removing a lot of these crutches, like simply looking at a bunch of examples. These examples don't add any more benefit, or writing the pseudocode before actually writing the code. In fact, he's actually done this twice. So this tells me that he is just still in the beginning stages of just trying to actually figure out the basics of problem solving. So in other words, he needs to look at trying to wean himself off of this. But so far, nothing really major from a coach's standpoint. But when we get to here, this is where the problems really start. So now that he realizes that this is not a optimal solution, that he's going to brute force an n-squared solution, he just tries to throw more test cases at this problem. In fact, he just tries to refer back to the original test case that we talked about before up here, and then try to solve them down here for various values. This tells me that he's just trying random things in order to try and hope that a magic optimal solution pops out. In other words, this is where the key points, the optimal solution and his solution, begin to diverge. In other words, he has no idea what to do after this point, after he's come up with a naive solution. So the lesson here is to realize that the optimal solution is often derived from many passes and attempts at the naive solution and just building off of itself. In other words, taking what worked and then trying to build upon it. And you can see that in this case, he does not actually do this. So this is another lesson that can be learned. Finally, we get to down here where he actually tries to solve the problem with a little bit of hint from my side, but he doesn't really make it that far, and in fact he just ends up writing a lot of gibberish and pseudocode without really understanding what he's writing. Now this is pretty similar to the previous mistake that he made with pseudocode, but again he doesn't really gain any more insight into how to solve the actual problem with this. In other words, his over-reliance on pseudocode is more form rather than function. So this is another lesson that he can take away. So if I were to actually write down these actual lessons, this is what it would actually look like. So if I were to actually write down all the things that I learned, this is how I would write them. Now this is a copy of whatever he did before, but I have highlighted my notes in yellow. In other words, first, you can see here that I made the same comment. Are these really necessary tests? Optimal solution only tested the current solution. Maybe if I can justify it by coming up with a pattern from all this effort, then this would be worth it. But ultimately, there is no additional effort. There's no additional value that is derived from all this. So you can see here that the way I'm thinking about all these different lessons and whatever I take away from the solution and whatever I'm trying to learn here is just simply a difference between what I have submitted, or in this case, whatever the client has submitted, and then whatever the optimal solution did in order to derive its answer. So you can see here, I'm repeating myself. What is really being tested with these numbers? These testing adds no additional benefit. I've marked here that the basic solution is fine, and it seems very similar to naive solution. And this is actually very important to do. I think people really try to beat themselves up over not getting the actual optimal solution or doing things the exact way the optimal solution did it. In fact, everyone's thought process is different. It's good to look for these inefficiencies and optimizations in your own thinking. Maybe the optimal solution does something that is better than what you did. Maybe the optimal solution does not. But what's important is that you can understand how the optimal solution was derived, and you can try and figure out how to actually incorporate that into your own thinking. In other words, if he made it this far and got a basic solution just simply by doing his own method, then more power to him. But as you can see here, he just simply did a lot of suboptimal thinking here and wasted a lot of time. So this is actually something, this right here, this testing is just way more of a concern. And then the next thing here, like I said, going along that line of thinking, all this additional pseudocode that doesn't add any additional understanding. This is also wasted effort and can also be parsed out. So I have this note right here. And finally, we see here the biggest problem of all, that he is trying a magic bullet solution for no reason. And so the biggest takeaway from all of this, from this entire exercise for this person, would be that, hey, there is no such thing as a magic bullet, and you try to find a magic bullet every single time, it will not work. This is the biggest mistake that I see as a coach from every single one of my clients, that they try to YOLO some kind of random solution for no reason. And so if this problem has shown anything, is that optimal solutions are derived from naive solutions and iterating over it. This is very similar to what we do in the engineering process and in any particular project in the real world. And finally, we just write this here. That, again, is just wasted effort, that there's no additional understanding that is written out here. You can easily talk through this process. You can write it out in very, very shorthand, just like I did in the optimal solution. But this, again, this is just a lot of words that contribute nothing. So with that, let's actually look at the second client before we actually look at how to record this in the diary. So here, we look at the second solution. You can see here that the client very much starts off in the exact same way. He just tries running through an example in order to try and make sure that he actually understands the solution, or at least tries to understand the problem. And with that, because of that, he was actually able to come up with a very, very short brute force solution. See, here he just was able to say exactly what the first client said, except he was able to compact it in one simple idea, and that is very, very easy to understand. Iterate over the array in order n. Build a range using those numbers, and then count how many numbers are in the range. Now, there's a lot in here that is implicitly assumed. For instance, build a range simply means that he is referring to this step, and then count how many numbers are in the range means that he's going to iterate over the array over again. And in this case, he already presents the idea and explicitly states the time-space complexity, which already tells me that he's already thinking and understanding the solution. This is very quick thinking, and he doesn't waste a lot of time like the first client. Now, going on, you can see here he comes up with a little bit of a weird solution, grouping into buckets. Well, the bucket idea is interesting, and maybe it can help him get to a more optimal solution, but this is kind of out of left field. So you can see here that he was actually trying to write out the structure, the variables that he was using, and using the DQ and X value in order to try and put elements into the DQ. And then from there on, he was able to take numbers out whenever they surpassed the range. Now, this is actually where I came in. This DQ didn't actually make much sense, and he was very, very gung-ho about trying to actually write this out. So essentially what he was doing was a very overcomplicated version of the sliding window, where he would actually take the value of X, add this value to the DQ if it was within the range, and then -1. Add it if it was within the range, and then 0 if it's within the range. And then once he got to a point where he hit a number that was outside the range, he would actually DQ everything and count them. So in other words, he was just storing a lot of these values for no absolute reason. Now, if he was able to actually think on this a little bit more and just simply say, hey, this DQ is presenting a lot of extra space that I don't need, he could have come up with actually a sliding window solution. But you can see here that he was actually just trying to straight up go for some code. And this is actually the part where I came in and said if there was a way that he could actually come up with this faster. This is actually why you see this order times space notation of order n log n and order 1. This is just a consequence of what the format of the interview that I was doing. So this is kind of my fault presenting it to you guys, in the sense that this is actually what he, this is the final result. This isn't actually the whole process of him thinking. But nevertheless, he was actually able to come up with a pretty good sliding window solution. So in other words, he was actually able to get to the optimal solution that I had presented before, except with a little bit of guidance. So in other words, we can actually take that moment when he needed a little bit of help from this DQ solution as the big point in mistake. So let's ask ourselves, why did this mistake occur? This mistake occurred because he was overcomplicating the solution a little bit, that there was no trail of thought between his naive solution and optimal one, that the clear logic, the optimization, wasn't actually fully understood. He understood that there was some kind of optimization that could be had with sorting, and that he knew implicitly that you could batch these in order to try and count the number of variables. But the problem was that he wasn't actually able to grow the solution. So let's actually mark this down at every single place that I mentioned. So let's actually look at the markdown here. And I've highlighted again these lessons in yellow. So it's important to actually mark down what you did well and what you didn't. In this case, I said here that the brute force solution was easily understood with examples and that the naive solution was proposed very quickly. This is a very good sign that you were actually able to start the problem-solving process very quickly. So I would say everything up to this point is golden and that this should be positive reinforcement. However, this is where we start getting into trouble with the buckets. And so I would mark that the buckets seem unnecessarily complicated and it's not clear where this idea came from. And so this would be a more of a yellow-red flag. It's not something I would harp on if I made this mistake and I was looking back on it, but this is just something to keep my eye on. If an idea doesn't have any continuity to the previous solution that I proposed, then that's usually some kind of red flag that I am yellowing just some random ass idea out there. And like we mentioned before, very rarely are these optimal solutions and these problems solved with just by a simple YOLO. Moving on, we can see here that there is no need for a DQ. This is, again, in the same line of thinking as these buckets. And so this is just more of an extension of trying to implement buckets without trying to latch on to the root idea, which is that you can take a chunk of this array and then reuse it. The same idea that allowed us to use the sliding window. In fact, you should have recognized that this O of n space for a DQ was just very inefficient and that you could actually improve it. Now, I'm not necessarily saying that this train of thinking is wrong. What I'm saying is that this train of thinking could be much more efficient. And so I would say that maybe there is something to be learned from the more optimal solution. That, you know, you could come up with a sliding window if you just thought a little bit more about the array holistically. But in this case, you could have also derived the sliding window if you just tried to make the order n solution just a little bit more efficient. Just think about why you need to have the DQ and that you could just solve this using pointers without having to create some auxiliary function or auxiliary data source in order to try and hold all these values. So the big takeaway here is that a lot of these unnecessary complicated solutions are very, very difficult to defang and really understand where they come from and follow the thinking. Now, the interviewer might let this go, because he might say, oh, it's a very interesting solution that you proposed. But the key thing is that you need to really understand where your solution is coming from and why it works. After all, the interviewer is eventually going to press on you and say, hey, do you really understand what the heck you're talking about? And this is where, maybe he might get in trouble, maybe not. But this is just an inefficiency to keep an eye out for. But the takeaway also would have been that you should have recognized this as a sliding window pattern. This is something that grokking talks about. And if you had studied up until this point and had followed my guide, you would have done a lot of grokking, a lot of leetcode, a lot of elements of programming interview, and this pattern should have come up time and time again. And this is one of the patterns that I tell people that they should automatically understand and know kinetically. So having made this mistake, I would immediately go back and try to redo that section of grokking. So with that, let's actually look at how I would record this in a practice diary. And I highly recommend that every single person out there who is watching this or studying for any leetcode or any interview should actually keep a practice diary. That is, you should look at every single problem that you do and then try to understand the mistakes that you make, why you made those mistakes, by diffing your solution or whatever you have done against the optimal solution, and then try to see where at what point your solutions diverge. Could you have thought or done some things a little bit better, like I have done here, where I have just simply looked at each of my client's solutions and then just saw where diverged from the optimal solution and said, hey, maybe at this point it could have been a little bit cleaner, you could have understood this a little bit better, and then come up with a better, easily more understood solution just simply by doing this one little step or by thinking in this little way. And I've highlighted those in yellow. So taking all those lessons, here is actually how I would record my own thinking and my own feedback. In fact, this is an exercise that I make all my clients do for coaching. So you take the date at which you did it and how long it took for you to go through the problem. And so you can see here that arbitrarily I've written 1 hour, but it's not uncommon for a lot of these problems that you absolutely focus on and try to think about like how you can do it better to take an hour. In fact, this pays off dividends. It's better to do this for one problem, spend an hour on one problem and really think about like where you went wrong and what you could do better, than to try doing 3 or 4 problems and then just spam your way through, because you're not going to learn anything like that. So we can just grade ourselves on how difficult the problem was. We say what the problem it was, and then we say what the optimal approach was, and then we write down everything that we learned from there. That what was the fault here and what I could learn from it and what I could do better. Essentially, all the things that I talked about before in the video. I write them here in this very easy to read comment or thought process, and then I just say what the big takeaways are. So in this case, he tried to do a magic bullet, he understood the naive solution, but he spent too much time trying to come up with some random weird test cases and wasted too much time with some additional pseudocode that didn't actually need to be written. It didn't enhance his understanding. Every single test should be objective and meaningful. It should be testing something, maybe some branching factor in your code, or maybe some kind of some other idea that was not thought about. And you can see here, I'm actually very, very forceful in my language, swearing notwithstanding, in order to try and emphasize a lot of certain points, especially this one. Optimal solutions are built on top of naive solutions, so I fucking shouldn't try doing magic random stuff, And so here I have written down how I have done the problem, or in this case, I've linked to the Google problem sheet that I've actually done all my workout on. Now, you guys can do something different. Maybe you guys want to do something with pencil and paper, scan it, and then upload it to your Google Drive. But personally, I am more of the habit of actually doing a mix between Google Docs and paper, simply because paper is a lot faster, but it takes some time to really scan it in and upload. Whereas with the Google Docs, you could just simply create another Google Doc and you'll have these links forever. And you can see here that I've done the exact same thing for the second client, that he was able to get to the naive solution and get a variation of the optimal solution. And then I've recognized that I've done well in order to get the naive solution. I did the exact same process of just try an example, and then I got there very quickly. However, he should have recognized that this was a sliding window pattern, and this is a fault. Again, the difference between what you did and the optimal solution are things that you should write down. The mistakes that you made, and the mistake here was using some random data structure and realizing that this was absolutely terrible and it just overcomplicated the process and thinking. And so you can see with that terrible thinking, I have really emphasized that this is something that should not be repeated. And so hopefully you guys understand how I am able to reflect on my own mistakes, take what is out there, and really try to use that in order to better my thinking. I'm not just trying to pour over it arbitrarily, because I feel that just trying to look at your own mistakes is simply very difficult. However, if you have a template and a solution that you can look at in order to try and understand and compare yourself against, it makes the process so much easier. So in other words, the way you should optimally study is look at your solution or whatever you came up with, look at the optimal solution, understand what it takes to go from your thing to the optimal solution, and then write that down in your practice diary, and then make sure you never repeat those mistakes again. This is very important to keep a practice diary like this. And again, this is something that I make every single one of my clients do. So with that, hopefully you guys understand how to solve problems and you've gotten a lot out of this video. And I highly encourage you guys repeat this exact same process for whatever studying you do. So that'll do it for me. Let me know what you think in the comments down below. Also, feel free to follow me on my socials where you can vote for what topic I cover next. And if you want to try and secure the next job offer and be yelled at in order to do all these interview practice diaries and these exercises, you can book me for interview coaching at eChanTech.com. If you like this video, please like and subscribe, and I'll see you all in the next one.